So here you can see a tour of our balloon payload. First of all, here's our payload container of styrofoam painted in neon orange with the wires which will hold the circuit board, which are here, and here we have some sort of strut structure so that we can have our camera facing that way, and the circuit board will rest on here and the batteries will be down there, and the antenna also in the center. This is the 1500 gram balloon still in the envelope, and here is the payload as such. You can see the circuit board here, and there's the battery holder holding 4 AA batteries. We will be using Energizer Ultimate Lithium for good performance. There is another battery connector, which I'll talk about in a moment. Here you can see our voltage regulator, which powers the whole of the board, and our main switch, which is here. And when I turn the board around, you see the Arduino Mega Pro from SparkFun. It's the 3.3 volt version, and we decided for 3.3 instead of 5 to avoid problems with mainly the GPS. So here's the regulator, and the green LED is tied directly to the regulator, so if this turns on we can see that the board is powered, and if the LED flickers we can also see that the power is low, that the batteries need to be replaced. This is a voltage divider connected to an analog pin of the Arduino, and this one measures the voltage from the batteries, and so that we can actually see on the ground what the battery voltage is. The yellow LED is tied to an Arduino pin and turns on if the GPS tells us that there is no satellite lock. Red isn't defined at the moment, but of course you could program it that it indicates an error or something like that. So the next main point is of course the GPS, which is here. It's an U-Blocks of Switzerland Max 6Q module, which is 7-tail antenna for a good view of the sky. Really good GPS this. It also can achieve at least a time lock inside if placed near a window, and if you go outside it really quickly knows its position after about a minute or so. So now we come to the measurements. There is a BMP 085 barometric pressure sensor on a SparkFun breakout board, which measures the pressure and also the temperature inside the box. Here we got on this long connector a Maxim DS18B20, which will measure the temperature of the air outside. And here we got on this connector a Honeywell HIH 4030 humidity sensor. It's a 5-volt sensor, but it's regiometric, so it also works at 3.3 volts. But I think on the next board we will use a 3.3 volt sensor, so this makes it easier to integrate and program it. This silver box here is the Radiometrics NTX2 radio, which transmit on a free frequency of 434,075 MHz, and transmits through, we got added some insulation here because it's not really stable in temperature. If it cools down the frequency shifts a bit. Here's a coaxial cable, and here is our lambda 4th antenna. So the wavelength is 70 centimeters, and this is a quarter of 70 centimeters, and also these ground plane wires, and they will form an X when in the box. So this is a very simple antenna, but it's good enough to hear the balloon over several hundred kilometers, as has been shown by other balloon flyers. Here, hidden behind the insulation, is a blue LED which will flicker as the transmitter works, so that we can also see that it is okay before launch. This is an open lock by SparkFun, which locks all the data coming over the serial port. We bought this because of easy integration, but on the later board I think I would rather use a real SD card on the SPI port. Finally, there's this IC here, that's a MOSFET controlled by the Arduino. Here we will connect 3 Energizer Ultimate Lithiums, so the MOSFET will control power flow into these wires. And this terminal will be connected to the wires, and as you can see there's a coil, and this coil will get hot, and if we cross on this first flight 22,000 meters, this coil will heat up because the MOSFET switches on, and it will burn through a cord, and thus cutting free the balloon, and then the parachute will deploy and the payload comes back to Earth. And we do this to avoid problems, first of all with the balloon bursting. This is quite an uncontrolled descent in the first moments, and also to not to go too high on our first flight.